All right, so this video, starting off our last unit, is going to be on sequences and series. So we're going to go ahead and start off by going over some definitions that are important for this unit. So the first is just knowing what a sequence is. And a sequence is an ordered list of numbers . So they are numbers written in a specific order. They have a pattern to them. Usually, well, always separated by commas. So one number, comma, another number, comma, another number. The term of a sequence is each number in the sequence. Next, we have finite sequences and infinite sequences. So a finite sequence is a sequence with a specific number of terms. So it has 5 terms and then it ends, or it's got 17 terms and that's it. An infinite sequence has an infinite number of terms, which means that once you start the pattern with the numbers, you literally keep going forever. You never stop. All right, so for the first example, looking at sequences, we're going to find the pattern . And the next 4 terms . Of the infinite sequence 2, 5, 10, 17. And you can tell that something is an infinite sequence because it has the ... on the end. So that's what's telling you that it keeps going. So the pattern here, if you look from 2 to 5, you go up 3. From 5 to 10, you go up 5. From 10 to 17, you go up 7. So we went up 3, then we went up 5, then we went up 7. So that means that the pattern here is that we are adding the next odd number. The pattern is we are adding the next odd number. So the next 4 terms, if we added 7 to get 17, then the next time we would have to add 9, and adding 9 to that would give us 26. Then we would have to add 11, and that would get us 37. So we added 9 to get 26. We added 11 to get 37. Then we would add 13, and that would give us 50. Then we would add 15, and that would give us 65. So those are the next 4 terms following that same pattern. Okay, next I want to describe 2 different types of formulas that we're going to be using to represent our sequences. So the first type of formula is an explicit formula. And an explicit formula means that you can plug in n to find the nth term. So if you want the 15th term, you plug in 15. If you want the 27th term, you plug in 27, etc. The other type of formula we have is a recursive formula. And for a recursive formula, you start at the first few given terms, and then follow the pattern to find the nth term. So with a recursive formula, if you want the 15th term, you have to start at the first term and find the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, and 14th, and then you can find the 15th. So typically if we're finding explicit formulas, or if we want to find a specific number, we typically are going to try to use the explicit formula if possible. A lot of these sequences have multiple different formulas you could use to write them. Some formulas are easier to work with, some formulas are harder to work with. And we'll look at those a little bit more the next couple days. So I'm going to give you a few different example problems. So for all of these examples, the instructions are to find the first 4 terms. So our first problem is going to be a sub n equals 2 times n multiplied by -1 to the nth power. And a sub n is kind of like y equals, you know, so in sequences and series, instead of saying y equals for a function, we write a sub n, and that shows us that we're talking about a sequence specifically. So if I want to find the first term, I say a sub 1. That's my first term. And then since the n is 1, I'm going to plug 1 in for the n's in the equation. So 2 times 1 multiplied by -1 to the first power, and so that is 2 times -1, which is -2. The second term is going to be 2 times 2 multiplied by -1 to the second power, and that's 4 times +1. The third term is 2 times 3 times -1 to the third power, which is 6 times -1. And the fourth term is going to be 2 times 4 times -1 to the fourth power, which is 8 times 1. And so that means that the first 4 terms of the sequence are -2, 4, -6, and 8. And then if I wanted you to find maybe the 20th term, you would say 2 times 20 is 40. And then -1 to the 20th would be a +1, and so your answer would just be 40. So this is an example of an explicit sequence. Whatever term you want, you just plug that number in and you have that term. All right, we're going to do another one that's explicit. So this sequence is going to be a sub n equals n to the third minus 10. So the first term is 1 to the third minus 10. 1 minus 10 is -9. The second term is 2 to the third minus 10. That's 8 minus 10, which is -2. The third term is 3 to the third minus 10. That is 27 minus 10, which is 17. And the fourth term is 4 to the third minus 10, which is 64 minus 10, which is 54. So the 4 terms here are -9, -2, 17, 54. And again, this is an explicit sequence. If I wanted to find the 87th term, I could just plug in 87, and that would give me that term. Okay, let's go ahead and do some recursive sequences. So this is our third example. So for the recursive sequence, your first clue that you're dealing with recursive is they give you a starting number. So they already tell you the first term, maybe they tell you the second term, maybe they say a sub 0 and they're talking about like an initial value. It's not considered an actual term, but it would be a value you could start with. And then after that, they give you a formula, and it's written kind of strange. So what this notation means, this is a sub n, and a sub n is going to represent the term that you want to find. A sub n minus 1 represents the term that came right before that. So I'm going to say this is the previous term. All right, so if we have the first term is 1, then the second term is the previous term, which was 1, plus 2 times n, the number that we're on, minus 1. So 2 times the second term minus 1. So I've got 1 plus 4 is 5. 5 minus 1 is 4. The third term is the one before it, that's 4, plus 2 times the term number I'm on, 2 times 3, minus 1. So that's 4 plus 6, which is 10, minus 1 is 9. The fourth term would be the one before it, which was 9, plus 2 times the term that we are currently on, which is the fourth term, minus 1. That's 9 plus 8, which is 17. 17 minus 1 is 16. I know I only wanted to find the first 4 terms, but I'm going to have you go ahead and pause the video and see if you can write out how to find the 5th term. So go ahead and pause it. So the 5th term should be 16 plus 2 times 5 minus 1. So 16 plus 10 is 26. 26 minus 1 is 25. So the first 5 terms were 1, 4, 9, 16, and 25. All right. One more recursive sequence. That's a lie, we're going to do 2. One more finding the first 4 terms. All right, first term is 8, and then a sub n is 2 times a sub n minus 1 plus 7. All right, so the first term is 8. The second term is 2 times the one before it plus 7. So 2 times the previous term plus 7. So 16. Sorry, I wanted to do minus 7. It's like, that doesn't seem right. All right, 16 minus 7 is 9. The third term is 2 times the previous term minus 7. So that is 18 minus 7, which is 11. The fourth term is 2 times the previous term minus 7. So 22 minus 7 is 15. So the first 4 terms, 8, 9, 11, 15. All right, now here's another example problem. We're still doing recursive. And here we're going to find the first 8 terms of, and they gave us the first term as 1. They gave us the second term is 1. So they gave us the first and the second term, and then they're saying the formula is a sub n equals a sub n minus 2 plus a sub n minus 1. So what this means here is that this is the term that I'm finding. A sub n minus 1 is the previous term. And a sub n minus 2 is the term before the previous term. All right. So the first term is 1, the second term is 1, the third term is the previous term and the term before the previous term. So that means we're going to do 1 plus 1. The fourth term is the previous term and the one before that. So we're going to say 1 plus 2 is 3. The fifth term, we're going to do 2 plus 3 is 5. The sixth term is going to be 3 plus 5 equals 8. The seventh term is 5 plus 8 equals 13. And the eighth term is 8 plus 13 equals 21. So the first 8 terms were 1, 1, 2, 3, 5, 8, 13, 21. And that sequence keeps going. That sequence actually has a special name. So see if you can figure out, some of you might recognize it, but if you've never heard of it, maybe look it up and see if you can figure out what the name of that sequence is. Okay, now we're going to start looking at series. So a series is the sum of the terms of a sequence. So you're still going to see that ordered list of numbers, but instead of seeing commas between them, you're going to see plus signs between them. A finite series is the sum of a sequence with a specific number of terms. An infinite series is the sum of all terms of an infinite sequence and then we have the nth partial sum, and the notation for this is S sub n. So A sub n represents a sequence, S sub n represents the sum of a sequence, and S sub n is the sum of all the terms up to the nth term. So if the partial sum is the fifth partial sum, then that would be S sub 5, and you would find the first term, second term, third term, fourth term, and fifth term and add them all up. So that's what the nth partial sum is. Okay, one more little bit on series before I go over some example problems. Is we have something, a type of notation that is called sigma notation. Some people call it summation notation. And sigma notation is a shorthand of writing out the sum of all these numbers. So sigma notation has the Greek letter sigma, which means add up all of this. It says from n equals 1 to k of a sub n. So what this means is plug 1 into the sequence and get the first term, then plug 2 into the sequence and get the second term, then plug 3 into the sequence and get the third term, and keep plugging in numbers until you get to the k term. and the k term could be the 27th term, it could be the 15th term, it could be whatever. So this is just a shorthand way of saying plug in 1, then 2, then 3, then 4, then 5, and get all the way to k. So this is really a shorthand way of saying find S sub k. Okay, now we're going to go ahead and do some example problems. So first example, we're going to find the fourth partial sum of a sub n equals -2 to the n plus 3. So when they said find the fourth partial sum, what they really mean is find S sub 4. And if we wanted to write that in the sigma notation, we would say we want to start with the first term and go to the fourth term. And we want to do it for the sequence -2 to the n plus 3. So I haven't actually done any of the work. I'm just showing you there's 3 different ways of writing this type of problem. Fourth partial sum, S sub 4, sigma notation. So I'm just writing it all the different ways. And now I'm going to go ahead and find those 4 terms. So the first term is -2 to the 1 plus 3, which is +1. The second term, -2 to the second plus 3, that's 4, that's 7. The third term, -2 to the third plus 3, -8 plus 3 is -5. The fourth term, -2 to the 4 plus 3, 16 plus 3 is 19. So S sub 4 is what I get when I add up 1 plus 7 plus -5 plus 19. And that is 22. All right, for the next example, we're going to find S sub 3 of a sub n equals 4 over 10 to the nth power. So S sub 3 is another way of saying find the third partial sum. And it's another way of saying start with n equals 1, go to n equals 3 of 4 over 10 to the n. So the first term is 4 over 10 to the 1. 4/10 we could write as 0.4. A2 is 4 over 10 squared. That's 4/100. We could write that as 0.04. The third term is 4 over 10 to the third. That's 4/1000. We could write that as 0.004. So that's the 4 in the thousandths place. So if I find the sum, I have 0.4 plus 0.04 plus 0.004, and that gives me 0.444. All right, next example, we're going to find from the sum from n equals 1 to 5 of 4n minus 3. So the first term is 4 times 1 minus 3, which is just 1. 4 times 2 minus 3 is 5. 4 times 3 minus 3 is 9. 4 times 4 minus 3 is 13. 4 times 5 minus 3 is 17. So we're just going to add all those up. We get 45. And I didn't write it, but another way to write the notation for this, you could say S sub 5. So this is the fifth partial sum. Okay, and then last example, we're going to find the summation from n equals 3 to 7. So notice this is different because we're not starting on the first term. And this is of 6n minus 3 divided by 2. So what this notation means is we're going to start on the third term and go to the seventh. This means that our answer is not s sub 7. This is not the seventh partial sum because I'm not adding the first through the seventh. I'm just doing the third through the seventh. So this is just a little bit different. So I'm going to show a little bit less work this time because I'm running out of space. So 6 times 3 is 18. 18 minus 3 is 15 over 2. 6 times 4 is 24. 24 minus 3 is 21 over 2. 6 times 5 is 30. Minus 3 is 27 over 2. 6 times 6 is 36. Minus 3 is 33 over 2. And 6 times 7 is 42. 42 minus 3 is 39 over 2. So if I add all of those up, 15 over 2 plus 21 over 2 plus 27 over 2 plus 33 over 2 plus 39 over 2, I get 67.5, and I'm okay with decimals here just because we're not rounding. That's a perfect answer right there.